Alright, so starting off the second part of Chapter 1 here, sections 1.5 to 1.8 with this warm-up. If you saw a diagram, we have to be careful that we're not assuming too much from it. So we can't assume something. We can't accept it as true without facts or proofs. So can you assume the following without any markings? That lines are straight. Yes, there's no special markings for a straight line. Okay, but for lines are parallel, we cannot assume that. We would have to show on our lines those additional arrows for parallel. If they have the same amount of arrows, they're parallel. Lines intersect at one point. There's no special markings for that. That point's our complainer. We can assume that they're all on the same plane when you draw them. Lines are perpendicular. We cannot assume that. If we have perpendicular lines, we have to make sure that we show that they're crossing at 90 degrees, that they form a right angle. And any angles, segments, and polygons are congruent. Even though they look congruent, we can't assume that. So we have to mark in things that are congruent. The same amount of tick marks. Okay, so this was from the investigation in the lab. A right triangle has one right angle. An acute triangle has three acute angles. And an obtuse triangle has exactly one obtuse angle. So for our right triangle, we would have to mark in that you have a right angle. For an acute triangle, all three of those angles are less than 60 degrees. And here's my obtuse triangle. I know that this one angle here is bigger than 90. Okay, so we can also talk about triangles instead of their angles by their side lengths. So a scalene triangle has three sides of different lengths. An isosceles triangle has either two or three congruent sides, and an equilateral triangle has three equal sides. So here would be an example of a scalene. All three of these sides are different length. An isosceles triangle needs at least two sides to be congruent. And an equilateral triangle has all three sides congruent. An equilateral triangle is also an isosceles triangle. Okay, so can we draw a picture of each of these following triangles? If it was an obtuse isosceles triangle, we'd need an obtuse angle and two congruent sides. That one is possible. If it's an acute right triangle, this one is actually not possible because right means 90 degrees, so it has to have a right angle, but acute means less than 90. So all of the angles would be less than 90. Okay, then an acute scalene triangle is possible. So all three of these sides are different length. An obtuse equiangular triangle. So obtuse means more than 90. Equiangular means they all have equal angles. So we cannot have three angles that are all more than 90. This one is not possible. Okay, then we'll define some quadrilaterals. So a trapezoid is a quadrilateral. That means it's got four sides. With at least one pair of parallel opposite sides. So here's an example of a trapezoid. Okay, a kite is a quadrilateral with two pairs of congruent consecutive sides. Remember, this word congruent just means in a row. So right next to each other in a row, we have our congruent consecutive sides. They are not opposite of each other. So there's our kite. Sketching these would help. Okay, a parallelogram is a quadrilateral with two pairs of opposite sides that are parallel and congruent. So there's a pair of parallel and congruent sides. Here's another pair. Basically is like a slanted rectangle. So a rectangle is the same thing as a parallelogram. So we know it's got opposite, parallel, and congruent sides. But we also know that it needs 4 right angles. Each angle is 90 degrees. Okay, so a rhombus is a parallelogram. So your opposite sides, are congruent and parallel. But each side is really congruent. So it's basically like a slanted square. So your square then has opposite sides, parallel and congruent. Every side is congruent, and it has 4 right angles.